Hey, welcome back to the Computer Hardware and OS Essentials lecture series. I created these custom lectures based on the A+ certification program, but with few enhancements to improve our IT technical skills and knowledge. So if you haven't seen my previous videos, I will leave a link in the description for the playlist. This would be our 6th lesson and we will go over storage devices. The objective of this particular lecture is to learn how data is being stored, such as devices, logical blocks, data storage units, etc. We will introduce you to the basic storage terms that includes IDE, SATA, SSD, SSHD, etc. We will cover types of drives and interfaces, optical drives and flash memory, and how we can select and install internal storage devices. Storage devices. So the primary purpose of a storage device is to store data, as is the term describes storage devices. They are typically non-volatile. I mean, almost always non-volatile, because that's how they store data. And it retains save data after a power cycle. So what non-volatile mean compared to volatile memory is that it can retain the information. So for example, in our previous lecture, we have went over RAM, or random access memory, that is considered as a volatile memory. So when you power down your computer, all the information contained within the RAM will disappear. But with non-volatile memory, which we use in storage devices, retain save data even after a power cycle or turn off your computer. So you could have save a file on your hard drive and you can shut it down, and you can come a couple of months or weeks later, and if you boot back up, your information should be there, assuming the storage device has not failed, right? So that's what it meant by non-volatile. So it doesn't erase data or drop data just because of it lose electricity or that electrical current to that chip or the platter. Data can be stored on therefore optical media, which are CD, DVD or Blu-ray drives. Flash media, we often call them flash drives. Magnetic media, which often known as the hard drives or disk platter drives, as well as the magnetic tapes, also considered as part of magnetic media. And also you can save data on cloud, such as Amazon AWS store, Google Cloud, Dropbox, etc. Keep in mind, the term cloud is being used to basically give that responsibility of storing data to a third party. So for example, let's say you use Amazon AWS, you basically storing your information or your data in Amazon servers. It doesn't mean that you eliminate the storage devices out of the equation, but basically means instead of you having a local storage device, the cloud system basically rely on a third party such as Amazon or Google to store your data, and they are most likely going to use magnetic media systems such as magnetic tapes and hard drives to store your information. I will not go over the cloud and how cloud works in this lecture. That will be a separate lecture. Today's focus is going to be the storage devices that you can physically install on a desktop, laptop or a server. So let's go back to the fundamentals of computer science. That includes how we store data. So bits and bytes is how we actually store data. Computers cannot understand human language. Computers cannot interact with what we call the analog signals. So computers interact with bits and bytes because they can easily represent digital signals. A bit is either a 1 or a 0. A byte has 8 bits in it. So if somebody asks you what's the difference between a bit and a bit is either 1 or a 0, and a byte contains 8 of those bits in it. Then we have the terms such as the kilobyte, megabyte, gigabyte, and terabyte, which most of us are familiar with. So a kilobyte is approximately about 1000 bytes, and megabyte is approximately about 1 million bytes, and gigabyte is approximately 1 billion bytes, and terabyte is approximately 1 trillion bytes. So in terms of storage of a computer, we define typically by megabytes, gigabytes, and terabytes, and is files like small files may be described based on kilobytes. Like for example, if I have a small text file, that text file may have a kilobyte value, and if you have a movie, you will have like a gigabyte value. But at the end of the day, all of these terms can be used to describe how much data or what type of data or how large the file is being saved on your storage devices. So here is a overview of units of storage with a little bit more detail and a little bit more information. So in addition to terabyte, if you go down the list, we have petabyte, exabyte, etc., etc. In modern 2022, the most common term that you will hear with respect to storage devices would be the terabyte or TB, which, as I mentioned, is 1 trillion bytes. And that's where we are right now. But in the future, I expect it goes up to maybe a petabyte in the next little while, like maybe within a decade, because the technologies are getting cheaper and being improved. So for your knowledge, you should know that this entire chart, you don't necessarily need to know the decimal size with respect to it, but you at least need to know how it goes from bit to byte to kilobyte, megabyte, like that order, because that will give you a better understanding of storage devices. Logical block addressing and capacity. So the logical block addressing, also known as LBA, is a common scheme used for specifying the location of blocks of data stored on a computer storage device. So what that basically doing is that when you are storing information on your computer, hard drive or your solid state drive or your SD card or a USB drive, the logical block addressing is a scheme or a methodology used by computer systems that will specify where the data being stored on that device. Low-level formatting is a sector marking written to the hard drive at the factory, and not the same as a high-level formatting performed for operating system installation. So what that basically means is that when you buy a hard drive, whether it's a solid state drive or whether it's a disk platter, it will have a formatting already done by the manufacturer, so that the operating systems such as your Windows OS or your Mac OS can detect those drives for reformatting at a high level, for operating system installation. So all storage devices that interact with things like Windows operating system will have low-level formatting already done to it at the factory, at the manufacturer. For it is also known as a sector markings, and that would be how your operating system going to detect that drive, and then you can do the high-level formatting with your operating system when you do the installation. Firmware, BIOS or UEFI, and the operating system use logical block addressing or LBA to address all hard drive sectors. Size of each block plus the total number of blocks determine the drive capacity. So this is one of another reason, like without going into any detail, like high level overview, why when you purchase let's say a 4 terabyte hard drive, you don't have entire 4 terabyte hard drive for storage, because some of the space on that 4 terabyte hard drive will be used for the purpose of low-level formatting, high-level formatting, and certain configurations that needed to be saved onto the hard drive with associated with LBA. So this is why when you buy a 4 terabyte hard drive, you don't get the entire 4 terabyte space in that hard drive, because some of the space is being allocated for the operations that needed to be done in order to save information to that hard drive. File systems used by storage devices. So file system used to manage data stored on a device. Overall structure the operating system uses to name, store, and organize files on a drive can be the best definition for a file system. So this is one of the best definition for file system. So if somebody asks you what is a file system, it is used to manage data and stored on a device, and the best way to explain it is the overall structure in which the operating system used to name, store, and organize files on a drive. So there are file systems such as NTFS, FAT, and FAT32, etc. And different operating systems and different versions of the operating system, such as Windows 95 or as opposed to Windows 11, may use different file systems. In Windows, each storage device or group of devices, which are called RAID, is assigned a driver letter, and it is called a volume. So the reason why you have a C drive, that's a volume that which the Windows is using for installation of its operating system. If anybody is wondering why Windows is using C drive, not A or B or D or E or etc., this is a legacy thing that Microsoft decided to keep going, because in the old days, long time ago, the other drives, A, B, is used for like 3.5mm floppy disk and CD drives, etc. And the C drive would always be the hard drive. I'm talking about like 1980s and 1990s, and the Microsoft decided to keep the same naming convention, and therefore even if you do not have a floppy disk, when you install Microsoft Windows, even in 2022, it will get installed as a C drive volume or C volume. And this is because in Windows, each storage device or group of devices will be assigned a drive letter. Formatting is the installation of a new file system on a drive. So when you decided what file systems to go with, for example, if you are using Windows, you probably want to do it in NTFS. That NTFS configuration being written onto your hard drive or your storage device or solid state drive is what we call the formatting. Formatting is not installation of operating systems. Formatting is basically making sure your hard drive can accept a specific type of file systems, so you're going to format your drive. And those formatting types include NTFS, FAT, FAT32 and FAT, CDFS, which is compact disk file system, or UDF, which is universal disk format. Those are used in the CDs. A newer version of UDF is used by DVDs and Blu-rays, but that is a different file systems compared to that of NTFS that being used on your hard drives that currently running maybe Windows 10 or Windows 11. So how do we rate hard drives? So we can rate hard drives in many different ways. This includes the physical size, storage capacity, read-write speeds, technologies in use, as well as the interface standards. So when it comes to the point technologies, there are many technologies, many electronic technologies in use, but the primary division, the overall division of technology is basically magnetic drives and solid state drives. Typically in the industry, we call magnetic drives HDDs and the solid state drives SSDs. And these are like the high level breakdown of technologies, but it doesn't mean they are exactly the same. For example, a Samsung solid state drive SSD is different from a Toshiba solid state drive in terms of technologies that they use for circuitry, as well as sometimes chipset, And same goes for the magnetic drives. Enterprise magnetic drives are different from non-enterprise magnetic drives, etc., etc. So they differ from each other. And interface standards also, typically we have things like IDE, SATA, connectors. Those are like specific interfaces that can be used by multiple manufacturers to interact with your motherboard. So that's how you basically connect your motherboard to the storage device. So let's look at the magnetic hard drives. So how magnetic hard drives are built is that it will have they will have 1, 2 or multiple platters, also known as disk, and they would be stacked together, spinning in unison inside a sealed metal housing. So they look like exactly like this. So you will have a bunch of platters or disk, and they will be connected to a motor in the center, and they will be spinning at the same speed. And a firmware would control how data reading, writing would happen, as well as how it will be interacting with the motherboard, like how it's going to communicate with the motherboard. The read-write heads are controlled by an actuator, which is basically a small motor. Actuator is basically one that can send this arm all the way to the center, as well as all the way to the edge of these platters. So that actuator is the one right here, which is a small motor that actually going to control all of these arms from moving back and forth. And data is organized in concentric circles called tracks, and tracks are divided into segments called sectors. And most current drives use 4096 byte sectors. So sectors are basically like small pieces that is being broken into on this platter itself, and how it's how data is written. So it's written into different sectors. And form factors for internal magnetic hard drives can vary for either 3.5 inch for desktop and 2.5 inch for laptop computers, as well as for servers. So servers can also take 3.5 inch or 2.5 inch hard drives depending on your server configuration. So on the left hand side we have a diagram explaining the image above. So the arm is like this is the arm, and that's the actuator, and then we have the read-write heads attached to this arm, and they are going across these platters, these multiple platters at the same time, reading data as it goes back and forth. So this is one of the reasons why magnetic drives or hard drives are a little bit slower compared to solid state drives, because it has a lot of mechanical components that and has to work together in order to read and write data onto these drives. Solid state storage, also known as SSD. So this is becoming popular in 2022 as the prices of solid state drives have significantly dropped over the past few years. So the solid state storage includes not only the SSD drives that we put it inside our computers and sometimes portable drives, but they also include the USB flash drives and memory cards. So for decades we have been using memory cards for our cameras and cell phones. Those are actually solid state drives, just like a SSD. It just happened to be a smaller form factor and may use slightly different technologies in terms of the hardware. USB flash drives go by many names. So they were known as flash pen drives, jump drives, thumb drives, and key drives. And flash drives might work at USB 2.0 or USB 3.0 speed and use FAT or exFAT file system typically. But however, you can also reformat your flash drives to work with NTFS as well if you wanted to do that way. Windows 10, 11, Windows 8, 7, all of those have embedded drivers to support flash drives. Same with Apple Mac OS. It has already drivers set up in the operating systems that can handle those USB flash drives. Memory cards might be used in digital cameras, tablets, smartphones, MP3 players, digital camcorders, or any other portable devices. And most laptops have memory card slots provided by a built-in smart card reader, and most desktops would have a smart card readers installed onto its systems. And you can buy those modules if you don't have one on your desktop, and install it by connecting them to the motherboard. When it's come to the point, servers, especially enterprise servers as well as small business servers too, but mostly enterprise servers, you will not most likely find a card reader. This is because there is very little need for a SD card reader on a server. Servers do comes with USB connections, including USB 3.0 connections in 2022. So if you really need a memory card reader for whatever reason, you maybe can install a external memory card reader, just plug it in for your server if you want to install something using a memory card. So typically enterprise servers and small business servers do not come with card readers. Secure digital SD cards are the most popular memory cards nowadays, and 3 standards for capacity used by the SD cards includes 1.x, which is regular SD, 2.x, which is the SD high capacity, also marketed as SDHCs, and 3.x. These are known as the SD extended capacity or SDXC. So in the market, you probably hear the term SD, SDHC, and SDXC. Not so much with the .x values. SD card comes in 3 physical sizes: full size, mini SD, and micro SDs. Those are international universal standard sizes for SD cards. SDHC and SDXC slots are backward compatible with the SD cards. So if you have a computer that can take SDXC, for example, you still can insert a SD card, no problem, which is the regular size, this SD card. However, you cannot use an SDXC card in a SD slot and an SDXC card in a SDHC or SD slot. So these are not backward compatible. So if you have a SD slot, you can't use SDHC card in it. And if you have a SDHC or SD slot, you can use SDXC cards in it because they are not backward compatible. SD and SDHC cards use FAT file system typically, and SDXC cards use the EX file system with its formatting. Solid state storage form factors. So when it's come to the point SSDs, the form factor is very flexible. So the physical form factor can be anything you can imagine, as long as the manufacturer decide that it is the best way to put all those chips together. The reason for that is, unlike those other hard drives such as magnetic drives with the spinning disk, the solid state storage basically use these chips. So you can see on this M.2 standard form factor, all of these black boxes, these squares, these are basically memory chips. So based on how you configure or arrange these memory chips in the physical space and the electronic circuitry that goes with it, you can have variety of form factors with solid state storage. So there is no limit to the form factor. So there are standard form factors such as these 2.5 drives as well as the M.2 form factors. So these are some standard international standard solid state form factors. But you could also have form factors like these. So these are Intel SSDs for servers. So in the enterprise environment, they have decided to go with this type of a form factor because that may be the optimal use of space. So if I put a pencil right next to it, the pencil would go from here probably down here. So these are very long form factor. This is a long box type or square rectangular type form factor, and that because it is solid state drives. So these are solid state storage devices. So these chips can be rearranged any way which the manufacturer deems the best option for that particular use. So as a result, we have standard form factors and proprietary form factors. As an IT technician, you should take that into consideration when you are recommending the solid state storage for your enterprise or home use environments. Proprietary form factors are, however, usually associated with servers in enterprise environment or specialized environments. So what that means is basically, I already explained how the Intel may decide this type of form factor is the best use with their Intel servers, for example. But also specialized environments mean that if you work for specialized organizations such as research laboratories or like a NASA or something like that, they may have a specialized proprietary form factors that will fit their need. So that is a good thing because it allows us the flexibility of putting this solid state storage anywhere where there is room, physical room in a device or an environment, right? Such as, like I said, like if NASA is doing a research and if they want to fit in a storage device in a very tiny, tight space on a space shuttle, for example, if they wanted to, very large storage capacities, they can do that because it is the solid state chipsets are very flexible compared to, let's say, a platter drives that I mentioned briefly on our previous slide. Physical form factors typically do not correlate with the technology in use. So that is another thing you need to understand. So technology that is in use on M.2 does not necessarily translate to cutting edge technology compared to a 2.5 inch SSD. So Samsung, for example, have SSDs that are 2.5 form factor that are actually faster, better, and newer cutting edge technology compared to some of the older Samsung M.2 form factor based solid state drive. So don't get fooled by the fact that M.2 may be a newer standard compared to 2.5. So don't get fooled that the M.2 actually going to have a better and newer technology or SSD technology compared to 2.5, because technology itself has nothing to do with the form factor or very little to do with the form factor. Solid state drive or SSDs. So solid state drives, they are commonly known as SSDs, also called the solid state hard drives, and there is a reason why we call it a solid state, because they don't have any moving parts. So compared to our platter devices, the magnetic platter hard drives with a spinning disk that actually been written onto using different sectors with a arm that goes back and forth between the spinning disk, solid state drives do not have such mechanical moving parts. So that's the reason why we use the term solid state drive. It is solid state. It does not have any moving parts. They are built using non-volatile memory, similar to that is used for USB flash drives. So it is not exactly the same as the USB flash drive memory, but it is very, very similar or closely related to USB flash drive memory because solid state drive use non-volatile memory. Remember, the volatile memory is the memory that we use in RAM, which we have discussed in my previous lecture. So if you haven't seen that lecture, please go ahead and watch that lecture before you can move forward with this lecture series, so you have understanding about difference between volatile memory and non-volatile memory. So in this case, it is non-volatile memory. That means if you power down your system, if you take away power to your solid state drive, you are not going to lose all the data that you have saved in that memory. Memory in an SSD is called NAND flash memory, and the lifespan is based on the number of write operations to the drive. So compared to the spinning disk, where there is no lifespan based on the number of read-write cycles, the solid-state drives have a direct correlation between the write operations to the drive and the amount of that write operations happening. So spinning disk hard drives do fail. Okay, they do fail, but however, there is no correlation between how much data has been written to the spinning disk hard drives, which are magnetic drives, and the failure rate. In solid state drives, however, there is a direct correlation between the number of write operations done as well as write operations done and the failure gonna happen. So there is a direct correlation. The lifespan has a direct relationship to the number of write operations, and this is expressed as TBW, also known as terabytes written, or DWPDs, or drive write per day. Solid state drives are more expensive than magnetic hard drives, but they are faster, more reliable, last longer, and use less power than magnetic drives. 3 popular form factors used by the SSDs include the 2.5 SSD, M.2 SSD card, and PCIe Express SSD expansion cards. So these are 3 most commonly used form factors in 2022. So if you look at the HDDs or hard drives with the spinning disk versus the SSDs, which are solid state drives, this is what you would get typically. So in a hard drive, we have platters, and we have a motor in the center of those platters right here that is responsible for spinning these platters at a specific rate. So for example, 7200 RPM, rounds per minute. Hard drives will spin that platter 7200 rounds every minute. That's the speed that which the platter will spin. So that's how some of the HDDs are rated. The 5400, 7200, 7400, etc. That's the spinning rate, and that will determine how fast this hard drive can read and write. And then we will have the read-write head, which can move back and forth with the arm that being controlled by a small motor right here. And that's how basically the solid state drive typically work. And they are shock resistant only about less than half of what the shock resistance of a solid state drive, as you can see right here, because these spinning drives, if you drop it hard on the ground with these spinning drives, may get misaligned with the actuator arm, or this component can move about, and that can cause your hard drive to completely fail. Compare that to solid state drives. They have chips. So the chips looks like these squares, or sometimes the chips can have different designs, not necessarily a square or rectangle, but typically it's a square or a rectangle, and they are NAND flash memory, and you will have a controller that will be responsible for writing onto these chips accordingly. So they are not going to be writing randomly onto these chips, so it will wear out evenly, and there is cache associated with the SSD, just like a CPU. That cache gonna create a buffer between the writing of and reading of data and accessing the SSD NAND flash memory. And keep in mind that just because of you have a SSD doesn't mean that it is 100% safe to drop it. But if you were to drop hard drives or storage devices on the floor, you are better off dropping SSD over a HDD. Another thing I want to point out is that even though the failure rate is very low for SSD compared to HDDs, if a HDD fails, it is much easier to recover data as opposed to if the SSD fail. SSDs don't typically fail, and it comes with some software. For example, Samsung and other companies, Toshiba, Samsung, etc., they do have their own like Western Digital software. For example, Western Digital SSDs will come with its software that will detect, it will predict failures much earlier on, and it will let the user know, hey, your SSD might fail, so you may want to back up your data. But however, and in a case of a complete failure, it is easier to recover data from these platters than from SSDs. But at the same time, we are talking about like 10,000 Canadian dollars or 7,000, 8,000 Canadian dollars sometimes to recover data from even a failed HDD, like a hard drive. So even though it may be easier to recover data from a failed HDD, it's still going to cost you an arm and a leg to recover data even from a HDD, because when SSDs fail, all of these chip might be fried out, and or the control or the cache is fried out, and there is no way to access it easily without using specialized tools, and those tools are expensive, more expensive than the tools that we would use in HDD. In HDDs, you can go to a dust-free lab, dust and particle-free lab, and they can open up this casing, and they may be able to read data from each of these platters. But again, it's going to cost like $7,000, $10,000 to do that. So please make sure you have a backup plan. Doesn't matter whether you use HDD or a SSD. So keep that in mind. Failure rate is lower in SSDs. It is more shock resistant compared to HDDs. However, when SSD fails, you could lose all the data, unrecoverable, no matter how much money you spend, depending on how the SSD is designed. So keep that in mind. Hybrid hard drives. So a hybrid hard drives, also known as HDDs, is sometimes called a solid state hybrid drive, also known as SSHDs. And they contain both magnetic and SSD technologies. So it has a SSD component as well as a spinning hard drive, like spinning platters. So the magnetic drive in the housing permanently holds data. So your data that you're saving to the drive will be saved on those magnetic spinning drives, not on the SSD side of things. The flash component, however, serves as a buffer to improve drive performance. So the read and write speeds may significantly improved by using these type of hybrid drives. The operating system must support a hybrid drive in order for it to function. So Microsoft Windows 10, 11, and Windows 8, for example, and all of those Windows versions, whether it's a Microsoft Professional or home use, all of them do support hybrid drives. This is a compromise between more expensive SSDs and cheaper hard drives. These are magnetic drives, so this is a compromise, right? So the SSDs are much faster than HDDs, but much more expensive per gigabyte, or per terabyte. So in that situation, you may be able to get away with using a hybrid drive. So you will get a faster drive access, read write access speeds, but at a cheaper per gigabyte or per terabyte cost, right? So that's why you might want to use with SSHDs. However, in 2022, the SSDs are becoming very popular over hybrid drives because SSD prices have fallen over the past few years to a point that is extremely affordable to just go with SSD over a hybrid drive. So this is basically, you are combining two technologies, SSDs and spinning magnetic drives, together to get better performance, but not necessarily a better reliability. In fact, reliability may be the same as that of a magnetic drive. Smart, not dumb. SMART, also known as the self-monitoring analysis and reporting technology, is used to predict when a drive is likely to fail. So System BIOS or UEFI uses SMART to monitor drive performance, temperature, and other factors. So for spinning magnetic drives, those magnetic drives, it monitor disk spin up time, distance between the head and the disk, other mechanical activities of the drive. So it will monitor all of those KPIs or key performance indicators to predict failures using that smart technology. For solid state drives, it monitors sector failures, bad sectors, temperature and heat statistics, and oftentimes custom and specialized software comes with your SSDs that can actually monitor those information and give you a warning. Those include the Samsung SSD Health app that you can install on your Windows machines as well as Mac machines, that will always monitor your Samsung SSDs and flag you if there is a indicator of a failure. If smart suspect a drive failure is about to happen, it displays a warning message, and it can be enabled and disabled in BIOS UEFI setup or via the vendor specific software or drivers such as the Samsung SSD Help app. Interface standards. So we're going to switch gear from looking at different storage devices to how those storage devices are going to interact with your motherboard. So there are 4 interface standards used by hard drives that include the IDE, SCSI, SATA, and NVMe. The IDE and the SCSI are legacy device interfaces, while SATA and NVMe are current devices as of 2022. So these are how the interfaces are how a hard drive or a storage device would gonna connect to your motherboard and other devices. So IDE, let's look at that interface standard. So IDE, also known as the parallel ATA or PATA, and it allows for 1 or 2 IDE connectors on a motherboard using a 40-pin data cable. 2 types of IDE cables are the older cable with a 40-pin connector with 40 wires, and a newer cable with the same 40-pin connector and 80 thinner wires are also available. The maximum recommended length of an IDE cable is 18 inches or less. So that is the maximum is 18 inches. You can go with these type of wires. And if you have done computer science or are familiar with building computers long time ago, you probably remember these ribbon wires, and this is basically the IDE wires. So it has a 40 conductor cables in this example, and this one has 80 conductor cables. So those are 2 different types, but the actual block here that connecting is the same. And the red line shown on the left side indicates the pin number 1. So that's how you know where the pin number 1 is. And you can have like 2 or 3 of these connected in series. Basically another connector here in here, for example, and you can connect your CD drive and your hard drive and etc. And this is how I did it when I was a 14-year-old kid about 20 years ago, connecting hard drives and CD drives onto my motherboard. So this is an older legacy standard. This one is also a older legacy standard. So in the past, the hard drives designed for a high-end workstations use the small computer system interface, also known as SCSI interface standard, and SCSI can support up to 7 or 15 SCSI compliant devices in a system. And the SCSI expansion card called the SCSI host adapter used a PCIe slot and provided 1 external connector for an external SCSI device and 1 internal connector for internal SCSI devices. So that's how it's gonna work. So it's again a ribbon cable, and it has a similar structure like this, the connector structure, but it's a slightly different standard. And again, this is also a legacy standard. SATA is a newer standard that is currently in use, and SATA SATA is mostly used in hard drives today, and they are known as a serial ATA or SATA. So that's how we use the terms for this standard. So we either call it serial ATA or SATA, and SATA uses a serial data path, and SATA data cable can accommodate a single SATA drive. So SATA cables cannot have it can connect like this. So see how it has multiple connectors in a one ribbon cable, and you can put one hard drive, another hard drive, and a CD drive like that. So that's what you can do with this, as well as you can do that with IDE cables too, but with SATA you can do that. So a SATA cable can accommodate only a one SATA drive, so one drive per cable. And there are three standards for SATA, that are SATA 3, SATA 2, or SATA 1. And SATA standards are used by all drive types. So these SATA standard can be used by all drive types. That include the CD drives, that include the hard drives, like storage devices, etc. So the SATA supports hot swapping, or also known as hot plugging, and can connect, and that basically means it can connect and disconnect a drive while the system is running. So if you have a secondary hard drive, for example, you would be able to either plug it or unplug it while the system is running. As long as it is not the operating system, you should not have a crash. And this is what the servers, enterprise servers and business servers, utilize for hot swappable hard drives. And SATA standard also connects to one internal SATA connector on the motherboard via a 7-pin data cable. So those data cables uses a 15-pin SATA power connector, which is a separate connector from that of the obviously the data cable, and that is specific to the SATA standards. So you have not only a SATA standard a data cable, but also SATA standard 15-pin power connector as well. A motherboard might have 2 or more SATA connectors, and in that case, you can use those connectors in order which the motherboard guide recommends. So if you have like multiple SATA connectors available on your motherboard, you should use it according to the motherboard manufacturer's specifications. Don't just plug it in a random SATA port. They may be labeled 1, 2, 3, 4, and you should be populating in that order. Also, one note here, some desktop motherboards have multiple SATA connectors that have hardware RAID or software RAID support, and I will discuss a RAID a little bit later in this slide set, but that's another reason why a motherboard might have multiple SATA connectors, not just to increase the flexibility, but also to support things like RAID configurations. So SATA connectors look like this, the wire look like that, and both ends are the same, and then the SATA power looks like this, and the other end of this power connector should be connected to your power supply unit, PSU, which we will cover in our next lectures, not in this lecture. And on the SATA standard, you can see the data cable get connected like that, and then it will connect to one of those motherboard SATA connectors. In here we have 1, 2, 3, 4, 5 connectors, and they are being connected through this data cable, and then you have to power it up with the power cables coming up here, which are not connected right here. So these are 3 solid state drives being connected to one single motherboard that can support up to 5 SATA connectors shown here. The SATA 3.2 revision allows for PCIe and SATA to work together in a technology called SATA Express that uses a newer connector, and SATA Express is not as fast as NVMe, but it is actually better than the previous SATA. So it is still faster than the previous SATA, but it is not as fast as NVMe connectors. A motherboard or expansion card can provide external SATA, also known as eSATA ports, for external drives as well. So in that case, what's going to happen is you will insert a card that will go into one of your expansion port, and on the back of your computer you will have a SATA output where you can connect a external SATA connection. External SATA, also known as eSATA, drives use a special external shielded serial ATA or ATA cable or SATA cable up to 2 meters long. So eSATA cables up to 2 meters long can be used to connect external or eSATA drives. In 2022, eSATA drives are almost non-existent in the field right now. Because with USB 3.0 and there's no need for this type of connection for faster speed. So that's why we have less and less. This is becoming more and more legacy type of technology, the external SATA or eSATA. Purchasing considerations that you need to take into account is that the SATA standards for the drive and the motherboard need to match. Otherwise, it won't either won't have the best performance rated output, or it may not work at all. And if they do not match, the system obviously most likely gonna be like not gonna have that performance that you need, rather than it's not working at all. Actually, yeah, that's what most likely gonna happen. So if you buy a SATA standard 3.2 version driver, but your motherboard only supports SATA standard 2, it's gonna have a slower speed. So that's what's going to happen. Yeah, most likely it's going to work, but it's not going to work at the speed which you would like to have it running. So now we're going to look at the NVMe standard. NVMe stands for Non-Volatile Memory Express, or NVMe Express. So NVMe is also known as Non-Volatile Memory Express because that's what it stands for, or sometimes known as a NVMe Express. It is an interface standard used only by solid-state drives. So those are only used by the solid-state hard drives. No other components actually use the NVMe standards as of 2022. So if you do a comparison, the most common SATA standard, which is a SATA 3, transfer data about at 6 gigabyte per second. So the maximum it can do is 6 gigabyte per second. NVMe uses the most common PCIe standard, which is a PCIe 3.0, which transfer data at a 32 gigabyte per second. So that is much faster, significantly faster than SATA's connection. The PCIe NVMe interface might be used in 3 ways. That includes the PCIe expansion card, U.2 slot, or M.2 port. So this is a PCIe NVMe expansion card, or the interface card, and this is allowing the user who might not have an NVMe connection on their motherboard to be able to use NVMe, and also may even set up RAID with it, because now it has multiple data storage units, right? So you have 4 of them, so you may be able to set up RAID with it. One caution that I want to point out with NVMe: in 2022, you can buy motherboards that already support NVMe, but not the speed at which it's designed to run. What does that mean is basically you could buy a motherboard that has a PCIe standard less than 3.0, but still has NVMe configuration. So basically I don't know why they do that. Asus has that, and actually I have a motherboard right now at home like that. It doesn't use the full PCIe 3.0 or 4.0 standards. It uses a less speed than that, and causing the basically create a bottleneck right there. So keep that in mind. I don't know why manufacturers do that. So that is an important concept that you need to know. So for example, you may buy a motherboard that is rated for NVMe, but make sure you check whether it's a PCIe 3.0 buses, and if whether it supports PCIe 4.0 buses. If it is 4.0, which is much better and have a much faster speed. So just because of if some manufacturers may say it's NVMe supported, doesn't necessarily mean it support at the 32 gigabyte per second or higher rate. So keep that in mind. You need to check the bus speed of your motherboard as well. Just a cautionary tale, because I bought a motherboard that I thought it is supported PCIe 4.0, but it's actually only support up to PCIe 3.0, and I get 32 gigabyte per second speed, but not higher than that. So that's why you need to be careful about when purchasing your motherboards. RAID. So I mentioned RAID couple of times on my previous slides, but I haven't gone into how RAID works. So in next few slides, I will introduce to different main types of RAIDs in use. And RAID is typically used by servers, but also may be available on your desktop motherboard as well. So let's switch gears and learn a little bit about RAID. Again, this is not a comprehensive RAID lecture. This is a high level overview of RAID that we're going to cover in the next few slides. So the RAID is defined either as redundant array of inexpensive disk or redundant array of independent disk. These two terms are widely used interchangeably in the industry. So either redundant array of inexpensive disk or redundant array of independent disk. I prefer the second version, the redundant array of independent disk, because that, to me, that describes what actually RAID is doing better than what is saying here. But either or would work in the industry. It is a data storage virtualization technology. So if somebody asks you describe RAID in a simplest way, you can say it is a data storage virtualization technology, and it combines multiple physical disk drives components into one or more logical units for the purpose of data redundancy, performance improvements, or both. So the primary purpose of the RAID is to the data redundancy, performance improvement. Those are the two key factors that we look at when we are looking at configuring RAID. They are almost always present in servers, but also available on modern desktop motherboards as well, because some motherboards do come with those multiple SATA ports. That would allow you to build either hardware or software RAID right on the motherboard. So it almost always you're going to find that RAID in servers for sure, but on desktop motherboards they are becoming more of an item that is already included in there. RAID can be either hardware RAID or software RAID, and hardware RAID has better performance compared to software RAID when they have done tests on those. And the RAID is not backup. This is very, very important. Even some IT professionals get confused with the idea that the RAID is backup, but RAID is not backup. And why is that? Well, let's look at why. So the reason why RAID is not backup is that RAID guard against one kind of hardware failure, hence it provides hardware redundancy. The primary purpose of RAID is not backing up your data, but guard you against a hardware failure, and it's a very specific type of hardware failure, which is a disk failure. So there are a lot of other things that could go wrong in a system that is not covered by RAID. That include file corruption, human error such as deleting file by mistake, catastrophic damage, that means someone dumps water into a server, or you suddenly had a power surge and it fries everything out, all the storage devices, something like that. Viruses and other malware, software bugs that wipes out data or lock your data where you cannot recover the data back, hardware problems that wipes out data or causes hardware damage. That includes a controller malfunctions, firmware bugs, and voltage spikes, etc., etc. All of those things, could cause hardware problems that may not be recoverable. So this is why RAID is not backup. What RAID, however, offer, especially why the enterprise servers and small business servers may use RAID, is it protects you against one thing only, that is a disk failure or disk failure. So a disk or multiple disk failures. So if you are a company, for example, enterprise servers have large amount of data and you put it on a RAID configuration, if a one disk fail, you can recover that data back, but it doesn't mean it's gonna be a backup solution. So RAID is not backup. Just because of you have set up RAID doesn't mean that you can ignore backup. So you should have a backup plan in your company or your organization where you back up your information, even if you are using RAID. You should have a backup plan at home. Like if you're going to school, if you're going to work, and if you're using your personal computer for your work, you should back up your work files and your personal files onto external hard drives or something like that. And if you are in an enterprise environment or small business or business environment, you may have off-site backup as well, because that will guard against things like fires or physical damage to your hard drive. So keep in mind, RAID protects against one and only one thing, that is a disk failure, nothing else. RAID is not a backup. It is a redundant hardware method. RAID is created for redundancy of disk, so the disk failures can be recovered, but it is not designed for as a backup. Because if your RAID card or RAID controller fail, even if you had RAID set up, you may not even be able to recover from the disk failure if you can't find the same RAID card in the market, right? So keep that in mind. Backup is not RAID. RAID is not backup. So what are the types of RAID? So originally RAID had 5 standard levels that goes through RAID 1 all the way to RAID 6. So current RAID standard includes RAID 0 to RAID 6, because RAID 0 is technically not RAID. So that's why original standard didn't have RAID 0. The newer RAID versions also have something called nested or hybrid RAIDs that include RAID 0 plus 1 and RAID 1 plus 0 and JBOD. And then there, we will go over a high-level overview of these items in the next few slides, so that you have a basic understanding of these types of RAIDs. So again, I'm not going to go into technical details on all of these RAIDs to the point that you will understand exactly how RAID works, but it will give you a very good idea how different RAIDs like RAID 1, RAID 2, RAID 3 or JBOD works, so that in the field, when you go out as an IT technician, you have a better understanding of which RAID you need to pick for your enterprise or business environment. So let's start with RAID 0. We consider this as a striping type, and it uses 2 or more physical disks and writes 2 physical disks evenly across all disks, so that no one disk receives all activity. So in other words, if you put a single file in a RAID 0, what's going to happen? The data on that file will be saved on both hard drives. So in RAID 0, for example, if you have 2 disks, here's disk 0 and disk 1. Data is, your data will be split across the hard drive. So A1, A2, A3, A4, A5, A6, A7, A8. So your file goes from A1 to A8, and they are splitting across the 2 hard drives. So they are evenly spread across the 2 drives. Windows call RAID 0 a stripe volume. So you can actually create a software RAID 0 on your Windows 10 and Windows 11 and even Windows 7 and 8 machines. I have already done a video on that on my YouTube channel. If you haven't watched that, you can go ahead and check my YouTube channel, and I explain how you can create RAID using Windows built-in software. Basically what it does is creating one single volume called stripe volume using Windows software that is basically doing RAID 0 striping. So that's what it is. And the problem with this is no drive failure data protection is given here. So there is no data protection here at all. There is no drive failure protection here. Remember on the previous slide right here, I said the RAID protector against one thing only, that is a disk failure. But this is why the original RAID did not have RAID 0 as a standard, because it actually doesn't even give that protection. So one hard drive failure here, you're going to lose all your data. So this is why the original standards had 5 standard, and that had RAID 1 to RAID 6, but not RAID 0, because RAID 0 is truly not RAID. It is not RAID. But however, you might ask the question, if it is not truly RAID, why do people even use RAID 0? The reason why people use RAID 0 in certain situation, because the benefit of RAID 0 is that the throughput of read and write operations to any file is multiplied by the number of drives, because unlike span volumes, reads and writes are done concurrently. So that means the read write access speed is going to increase as opposed to using other type of RAID. So if you want to increase the capacity, your storage capacity, by combining drives, combining storage volumes, RAID 0 will increase the capacity but also give you a higher read write speeds for whatever the applications you need. But the disadvantage is if one of those hard drives fail, you lose all your data. There is no redundancy here at all. So that's something that you keep in mind. And this is not a original version of a RAID, as it is not truly RAID, right? So that's why. So RAID 1, which is mirroring. So RAID 1 is also called the mirrored volume. That would duplicate data on one drive to another drive and is used for fault tolerance. Data mirroring is done without parity or stripping. No data should be lost if the drive faults or fail, if one of the drives faults or fail. And typically highest performing RAID level is considered as the RAID 1 because this provides the best data protection for your configuration, right? And however, the downside of RAID 1 is as a result, because we are using an entire hard drive to basically copy data. So in this here, we have a data file with A1 to A4, and those data is basically mirrored or copied one-to-one to the next disk. So that whatever the data in the disk 0 is being copied to the disk 1. It is mirroring the data in one disk to the another disk. As a result, basically you're gonna drop your capacity by half. Why? Because if you have 1 terabyte disk here, 1 terabyte disk here, the RAID 1 basically not gonna give you 2 terabyte like RAID 0. Instead, you're still gonna get just 1 terabyte. So you have 2 terabytes worth of hard drives, but you only have usable storage space of 1 terabyte. So the actual read throughput of most RAID 1 implementation is also slower than the fastest drive. The write throughput is always slower because every drive must be updated, and the slowest drive limits the write performance, because every single time you write to RAID 1 configuration, it not only has to save on one of the hard drives, it has to save on 2 hard drives, right? It has to mirror that information. So as a result, the throughput of RAID 1 read writes are very slow. The array continues to operate as long as at least one drive is functioning. So one of the key features of RAID 1 is that if I take out this hard drive, you will still be able to access all the data and the entire RAID volume will still work. You will get a warning in most RAID software saying, hey, a driver has failed, please replace the degraded drive. But however, your device will be still running and you can still obtain the data and work with the data with just one drive running. And when you insert the new drive, it can rebuild it. And one more thing that is not mentioned here, these two drives have to be the same capacity as well. Otherwise the RAID only gonna see the lowest capacity. In some RAID software it will take in two different capacities, but the lowest capacity drive will dictate what going to be the RAID configuration. So if you have a 2 terabyte drive and a 1 terabyte drive here, both of them going to look at as 1 terabyte because that's the lowest capacity. And some RAID cards can't even do that. Some RAID software and cards cannot even do that. So you have to have both the same 1 terabyte 1 terabyte. You can have 1 and 2. Some RAID cards and software you can have insert 1 terabyte drive and a 2 terabyte drive, for example, but it's going to look at it as a 1 terabyte drive at the end of the day because that's the lowest capacity one. It's going to dictate what this RAID mirroring volume going to be. RAID 2, which is striping with parity. So RAID 2 is not widely used in the industry. It does provide data protection because unlike the RAID 0, for example, this one has error correcting codes as well as a parity built into it. And parity hard drive requirement is proportional to the log of the HDD number, the hard drive number, and somewhat inflexible and less efficient than RAID 5 and RAID 6 with lower performance and reliability. So we will discuss RAID 5 and RAID 6 in the next few slides. Again, this is not a RAID version that is widely used, and I'm not going to go into depth of how striping and parity works in this lecture because we are just looking at RAID high level overview. So as an IT technician, you can go to the field and advise your clients on best options available. I'll do a different lecture on how RAID works later sometime. So now just remember RAID 2 use striping with parity, and we don't typically use that in the industry nowadays. Same goes with the RAID 3, which is also used as striping with parity. Again, not typically used in the field in modern day right now. And it is similar to RAID 5, but blocks are spread across hard drives. Parity is something called bitwise as opposed to RAID 5 blocks. Again, I'm not going to go into depth of what are the differences between bitwise parity versus the RAID 5 block parity. Just so you know, it is different from RAID 5, even though RAID 3 is similar to RAID 5. It uses different types of parity. And the parity reside on a single hard drive rather than distributed among all disks. That's another problem with this type of RAID. And the random write performance is very poor, and the random read performance is fair but not the best. And as a result, again, RAID 3 is not widely used or implemented in the modern day industry. RAID 4, which is striping with parity. So striping with parity is the way that how RAID 4 works, and it is a type of RAID that is currently widely in use and adapted in the industry. So similar to RAID 3, the RAID 4 used the striping with parity but stripes data across many hard drives in blocks instead of RAID 3 bytes. So this is now striping data in blocks as opposed to bytes, and provides better performance and better random read speeds. Data protection is provided by dedicated parity hard drive. Again, it has a dedicated drive. In this example, it is the disk 3. That would be the parity drive that's gonna provide the data protection. Similar to RAID 5, except uses dedicated parity disk instead of distributed parity, and dedicated parity hard drive remains a bottleneck as a result, especially for random write performance, because of the dedicated hard drive needs to be accessed. That's going to create a little bit of a bottleneck as it's trying to write that parity onto that dedicated drive. An advantage of RAID 4, however, is that it can quickly be extended online without parity recomputation, as long as the newly added disk are completely filled with 0 bytes. So in other words, like if the newer disk is a brand new disk, So you remove this disk 0 because disk 0 failed, and you inserted a new disk, and if it is a brand new disk, it's just going to quickly build the entire RAID 4 structure, and recomputation process is much less resource intensive. RAID 5, again a very commonly used type of RAID, right above RAID 4. In fact, this is the most commonly used RAID type in 2022, and it is a striping with parity type. So RAID 5 gives us RAID 0 performance with more economical redundancy, because remember, in RAID 0 you give a really good performance, but doesn't have redundancy built into it at all. But the RAID 5 addressed that issue. Stripe data across several drives while distributing parity among hard drives. So instead of having a dedicated parity hard drive, now you will have the parity distributed. In other words, those error correcting or the data recovery information will be spread across a hard drive. So you can look at the parity as a data recovery bits that been spreading across. Again, I'm not going to go into depth in this lecture, but I will in a separate RAID lecture. But just look at parity in a way that it is like a way to recover data. Data protection, use parity from a failed drive to reconstruct the drive. So that's how the data protection is provided in RAID 5. And stripe across data drives and uses parity checking, and data is not duplicated. So the RAID 5 stripe data across drives and uses parity checking, and data is not duplicated as a result of it. So the mechanism does not duplicate the data. Instead, it just stripe it across hard drives and use the parity across the hard drives as well. So the RAID 5 as a result is very efficient in terms of space, so hard drive space. So the overlapped read-write operations also become very efficient because not only space is efficient, but also it is a much more efficient in terms of read-write operations. Read performance is typically lower than other RAID types because the parity data has to be distributed on each hard drive. However, it is still efficient. And more usable storage space than RAID 1 or RAID 10. So keep that in mind. So it gives you more storage space compared to, let's say, RAID 1, because remember, RAID 1, if I put 1 terabyte hard drives, I'm going to end up with 1 terabyte or less, right? So as opposed to this one, it will give you more storage space for the amount of gigabyte hard drives that you're going to put into a RAID 5 array. RAID rebuild operations causes significant performance issues. So one of the issues with the RAID 5, it does create a significant performance issue whenever you have a rebuild situation where you have a failure of a drive. So if you have a drive failure on a RAID 5 and you insert a new drive, you will significantly reduce the read-write operations during that rebuild process. If a second drive fails during a rebuild of a RAID 5, almost always data will most likely not going to be recoverable. So that's another problem with RAID 5. That's why I always say RAID is not data backup. RAID is not a backup solution, right? For example, if the second drive fails in the RAID 5 configuration, and you may not be able to recover it. And also a RAID 5 cannot be built with just 2 drives. It needs more than 2 drives. So that's not mentioned here, but yeah, keep that in mind. And there are many layouts of data and parity in RAID 5 disk drives array depending upon the sequence of writing across the disk that that's gonna be, right? So there are multiple ways of how the layout of data and parity in RAID 5 gonna work. Those includes the sequence of data blocks written left to right or right to left on the disk array of disk n to disk 0 to nth number of disks. Like for example, the data can be write like this way. So it start from disk 0 and then go to the nth disk. the location of the parity block at the beginning or the end of the stripe, and the location of the first block of a stripe with respect to a parity of the previous stripe. So that's how basically the RAID 5 work. Again, this is an overview of a high level overview of how RAID 5 work. For example, I didn't talk about the minimum disk requirement for RAID 5 like sometimes I do on some other RAID options that I'm going to explain. But you know, again, this is just basic overview of how RAID works, so that you have a better idea about how these type of storage systems work. RAID 6, which is striping with double parity. Again, this is also a commonly used RAID type in 2022, striping with double parity using RAID 6, and similar to RAID 5, but includes a second parity scheme distributed across hard drives within the RAID group. So basically RAID 6 extends the RAID 5 by adding another parity block. So it is using block level striping, and it basically extends the functionalities of RAID 5. Dual parity protects again data loss in case of a second hard drive failure in this situation. So remember, in RAID 5, if the first hard drive fails, you're okay, and the second hard drive fails, yeah, you're not going to be okay. You're going to have some issues. You won't be able to recover data. So that's the key thing about the RAID 6. It should allow you to have 2 hard drive failures and still recover data. And it tends to have a lower storage system performance than RAID 5, so that's a disadvantage. And RAID rebuild operation causes significant performance issues, even worse than that of the RAID 5 rebuild operation. So if there is a hard drive failure, especially 2 hard drive failures, and you insert 2 brand new disks, it's going to create a huge bottleneck during the operation of rebuilding of that RAID 6 array, because you know it takes a lot of resources to rebuild that array. Nested or hybrid RAID. So there are a few nested RAID, which are basically combination of 2 or more different types of RAID. Typically it's just 2, and they includes the RAID 0+1, or sometimes called 0.1, and it creates 2 stripe and mirror them, and RAID 1+0, also known as RAID 10, that use the RAID 1 stripe, but that improves the write performance. RAID 5+0, also known as RAID 50, that is a type of RAID 5 stripes that improves write performance to bring it closer to that of RAID 1. And RAID 6+0, also known as RAID 60, that a type of RAID 5 stripes that improves the write performance to bring it closer to RAID 1. Again, I'm not going to go over all of these items in detail in this lecture, but I might do a separate complete lecture on RAID and how RAID works, and go into detail on parity and striping and all of these items, as well as in-depth analysis of nested RAIDs. But for now, just know these types exist and what they are and what they means. JBOD RAID is also typically known as also known JBOD, or just a bunch of disks, and JBOD creates one large logical drive from several smaller drives, and if a drive fails, only one data stored on other drives can be recovered, and not really considered as typically RAID, in a sense that it does not satisfy the original concept of RAID, but it is still part of a overall RAID or a structure that we use today, and often refer to JBOD as the spanning RAID as a result. Again, I'm not going to go over the nested RAID types, including JBOD RAID, right now in depth, but I will do it on a separate video just to keep this video as short as possible. This is already a long video, so that's why this lecture needs to be cut down a little bit. But this will give you more than enough information for your A+ certification exams, as well as some hardware exams in your whatever junior level hardware exams that you are taking in your schools. So let's look at the difference between hardware RAID and software RAID. So hardware RAID is a dedicated processing system using controllers or RAID cards to manage the RAID configuration independently from the operating systems. So that is basically what the hardware RAID is. Basically, you have a hardware component that has a dedicated processing system using controllers or RAID cards to manage the RAID configuration independently that of your operating system. So with hardware RAIDs, you need to get an additional RAID controller, also known as RAID RAID card sometimes, and that controller will be responsible for that hardware RAID configuration. However, RAID controllers on board the motherboard or dedicated RAID controller cards like the two options that you have. So you do have the option of some motherboards where the RAID controller is already built into it, so you don't need that dedicated card. But at the end of the day, either way, you require that additional RAID controller. So it's a hardware controller. It could be a chip on your motherboard already built in, or it could be a separated dedicated RAID controller card. If the RAID controller fails, you must find a compatible or exact same controller model or the motherboard to recover the data. So if you have a motherboard with the RAID controller already built into it, the chip is already machine sorted onto the motherboard, then you need to find the exact same motherboard to recover your RAID configuration if the RAID controller fails. But most servers would have a dedicated RAID controller card. You can simply replace the controller card with the exact same compatible RAID controller card, and then you can recover data if the RAID controller fails. This type of RAID, the hardware RAID, is efficient in rebuilding and recovering of data when storage drivers fail, because as opposed to software RAID where there is a overhead, when there is a hard drive failure on your RAID array, the rebuilding and recovery of data would be much more efficient because it has a dedicated processing associated with the RAID configuration. Almost all servers in 2022 uses hardware RAID. I never seen a enterprise server without hardware RAID, and I never almost seen even a small business server without a hardware RAID, even in 2018. As far back as 2018, I haven't seen that at all. So almost always you will have hardware RAID on servers. Software RAID uses the processing power of the operating system. It is cost efficient, almost always slower than the hardware RAID in terms of rebuilding operations and configurations. And configurations are often specific to operating system or the specific RAID software. And the RAID recovery is more complex and time consuming as it needs to use the operating system to configure those RAID options. So why would anybody use software RAID? Cost efficiency would be the key reason why somebody would use software RAID. So you may have a home computer that have a motherboard that can support software RAID. So you can basically create a software RAID for very cheap, as opposed to going through buying a RAID card or a specialized motherboard that has a RAID built into it with the hardware RAID support to get that done. So the RAID cards, for example, on the right hand side you can see it looks like these. They typically go into your expansion slots, and it will give you the connection to hard drives. So like for example, in this RAID card we have a connector here, connector here, connector here, connector here. Those are like, I believe, SATA ports, and that allow you to build hardware RAID using this RAID card. However, these RAID cards can go up to like $1,000 depending on the type of the RAID card and what features it support. And these are typically found in servers but can be installed on your desktop computer as well. So the reason why somebody want to use software RAID, because of the cost. It is much cheaper than the hardware RAID. Now the question is that is hardware RAID is better than software RAID in terms of redundancy, because the whole point of RAID is redundancy? The answer is no. It doesn't really matter. Both of them do support, give you redundancy. It's just the software RAID will have an overhead. In other words, you would be able to recover hard drive failure in the similar way, at a similar level, like in terms of like a successful hardware failure recovery would be similar between the hardware RAID and software RAID. It just basically, this one is having an overhead, this one doesn't have that overhead. And I would say in terms of reliability, maybe hardware RAID is little bit more reliable than the software RAID, but it's not a big deal for a home user. It is for a server enterprise environment. That's why we actually use hardware RAID only in enterprise environment. Another key point that you should be aware of is that not all hardware or software RAIDs are created equal. So if you take a bunch of software RAIDs options and you look at against each other, they are not the same. Windows already have a built-in software RAID in the device manager. You can actually use multiple disks to create software RAID with the built-in options, but it doesn't mean that's the best option. So not all hardware and software RAIDs are created equal. And when it comes to the point hardware RAID, I believe I don't have to explain that to you, because these card manufacturers have different chipsets, different processors, different cache, because RAID requires sometimes cache memory, and those chipsets and processors and this card builds are different from each hardware manufacturer, and therefore they are different from each other. So not all hardware or software RAIDs are created equal even among them. So keep that in mind. Optical disk and drives. So CDs, also known as compact disc, DVDs, also known as digital versatile disc or digital video disc, and BDs, also known as Blu-ray disc, use similar laser technology. So CD, DVDs, and BDs all use similar type of laser technologies to read and write onto those discs. How all of them typically, like overall high level overview of all of those three is how they work is basically tiny lands and pins on surface represent bits and read by a laser beam. So there are really tiny lands and pits on the surface of those discs, which you can see with your eyes, but naked eye, but you can under microscope, for example, and reading those bits, those lands and pits basically represent the bits, which basically read by a laser beam. Optical disc can be used for to write data. So one side of the CD can be write data, and one or both sides of the DVD or Blu-ray disc can be used to write data. DVD or Blu-ray disc can hold data in 2 layers on each side as opposed to a CD. So that's a slight difference between those two. Optical drives and burners. So Blu-ray drives are backward compatible with DVD and CD technology. So if you have a Blu-ray drive on your desktop computer or laptop, you would be able to insert as DVD or CD, and you should be able to still read and write to that. DVD drives are backward compatible with CD technologies, but cannot be used for reading or writing Blu-ray. Depending on the drive features, an optical drive might be able to read and write to Blu-rays, DVDs, and CDs. So some of the drivers in the old days didn't have the right options, but nowadays in Canada, at least in 2022, almost every DVD, CD, and Blu-ray drives are burners too, because the costs have significantly come down. And I hardly see just optical readers. Right now it's optical reader and burner, both together. A drive that can write to disk is commonly called a burner, because it basically burns with a laser, that's why. So today's internal optical drives interface with the motherboard using a SATA connection. Remember the SATA connection I covered with the hard drives? That's what almost all of, actually every, not almost every single optical drive use is SATA connection to interact with the motherboard. An external drive might use an eSATA or a USB port, but then again in 2022 eSATA is being phased out pretty much by the market, so an external drive might most likely use a USB 3.0 or USB 3 and up port to interact with your computer. So finally, this is just a basic overview of how you can install storage devices. I'm not going to go into detail on exactly the process for installation these devices, because it is same for most devices that you will be installing internally on a computer. So installation of internal storage devices follow the same principles as of any other internal component of a computer, server, or a laptop. So it's very similar. So follow the manufacturer's guidelines as well as the device specific guidelines. For example, vendor specific form factor SSDs must be installed according to guidelines of those specific manufacturers, such as the vendor specific SSD form factor that I've shown with the Intel device that I've shown in the previous slides. Make sure to use compatible components and use anti-static tools such as straps during installation process, so you don't fry out any electronic components on your motherboard or the RAID card, for example, for that matter. And make sure that your power supply unit, also known as PSU, can handle any additional storage devices such as RAID controllers, etc., because they will be drawing extra power from your power supply unit. We will go over power supply units in my next lecture in this series, but just make sure that your power supply unit can handle whatever the new devices, the storage devices that you're going to be adding onto your computer or server or laptop. And install any supporting software such as Samsung Magician software, RAID controller software, etc. for enhancements and storage health monitoring. Remember those Samsung Health softwares or the Toshiba or Western Digital software that would be monitoring your SSDs or hard drives with smart technology. So I would install those softwares almost always, every single time, so that you could get all the supporting programs onto your computer, right? Because that way, for example, if you install the RAID controller software, it may be able to detect RAID failures or hard drive failures within the RAID array, days, weeks, or months in advance. So that's why you need to make sure that you install those software, that you get the optimal advantage out of those items. One more thing that is not described in here, when installing any components on a laptop, as I mentioned in my previous lectures, that please check with the manufacturer's warranty. You don't want to be in a situation that you are trying to add or remove items from a laptop, storage devices from a laptop that is under warranty, and by doing so you may be voiding that warranties program. So be careful with laptops, because especially with laptops, as soon as you open the back panel or the front panels, like the keyboard panels for example, sometimes that would void your warranty. And that would be the end of this lecture. Please thumbs up this video and subscribe to my channel. And until next time, good luck and have a nice day.